you can imagine how incredibly lucky it is if we actually end up with fertilization as a possibility. So let's bring ourselves back. We know that the corpus luteum is going to do its thing, but we're going to try to get pregnant before the corpus luteum dies, knowing that we have 24 hours from ovulation. I brought us back to this picture because I wanted you to remind yourself of what the secondary oocyte looks like when it's floating in the fallopian tubes. So remember, it's surrounded by the zona pellucida and corona radiata. And basically this is like a huge barrier for the sperm. It's like a protection. Like, how serious are you? Are you really serious about being my sperm? Because if you are, then you will go through all my layers of protection in order to get in here. Wow, there's all sorts of levels of that we do not need to talk about ever again. Okay, what did I just draw? This is corona radiata, and this is zona pellucida. And who's this guy? Oops. That's my nucleus. And this is my secondary oocyte. And this is now chilling in the fallopian tube with just 24 hours to live. So who needs to come into this situation? Okay, it's going to be the sperm. And we have to draw a picture of the sperm, but of course we do. Because we have to, like, there's some facts about our sperm here that are really interesting. First of all, this sperm is enormously blown up. It is tiny. In fact, if I were to draw a sperm here, it probably would look like this. It would be like that big compared to my secondary oocyte. So the size is not appropriate or accurate. It is appropriate because that way we can see what I'm drawing here. What do you think this is? Color-coded accurately. This is the DNA. This is the nucleus. You'll notice how much of the cell is nucleus, like most of it. In fact, that's the whole point of a sperm, is just to deliver DNA. Nothing else matters. It has a structure in the tip of its little nose here. This is called the acrosome. And the acrosome is filled with enzymes, digestive enzymes. Take that one for a couple spins in your brain and see what you think we might be digesting. We have our rock and tail because, you know, you got to swim. I mean, think about how far these guys have to go. They're the tiniest cells in the human body, and they have to swim on their own awesome power. They have to swim from the testes of the fella up, and, you know, they really don't quite start swimming at that point until they exit. So they have to go up the vas deferens and into my 3 flavors of urethra in the fellas and out the spongy urethra, and then into the vagina at whatever point they get deposited in the vagina, then through the cervix, which, I mean, think about the cervix. Like, we're all little miracles. If you think about the cervix setting down in the vagina, the tube, the muscular tube, like, how easy would it be to swim? I mean, you're a sperm. You can't see a thing. There are, like, chemicals that sperm, they think that there are chemicals that sperm can follow. Like, they can sniff it out and, like, sniff out the egg. Like, let's go this way. But how easy would it be to take a wrong turn and go up the side of the cervix and get stuck in a little dead end? And then, dude, how awful is that? Like, that was your shot, and now you're stuck swimming in circles around the edge of the cervix on the side that you can never come back out through, and everybody else got a head start, and you're still there. But if you're the lucky one and you make it through the cervix and now you're in the uterus, and that's not even far enough. Now you have to go up the fallopian tubes, and there's 2 of those things. And you have to flip a coin and be like, oh, which one is it? I'm feeling the love that way. And then you pick a side and you go up that side, and hopefully you made it before 24 hours was up, and the egg, the secondary oocyte, is still there. If it is, and this is crazy, from 200 to 500 million sperm in every single ejaculation, shocking, so many of them got stuck in the cervix and like got turned around spinning. In fact, dude, how about this fact? Only 30%, that can't be true. Okay, only 70% of your sperm have to be healthy swimmers, and you are still perfectly fertile. So 30% of your 2 million sperm can like swim in circles or have 2 heads or like have tails that are broken, and you're still completely 100% fertile. So of your 200 million, 100 make it to the egg. 100 lucky friends. And so you're going to have 100 little sperm outside this egg trying desperately to get in. They use the enzymes in their acrosome to burrow in, to burrow through the zona pellucida, and if they burrow through, the first one through, this is crazy. There are, it's just so cool. There are little sperm receptors on the egg's cell membrane. This is inside zona pellucida. So it's actually on the cell membrane of the egg. There is a little sperm receptor. And if the first sperm that gets in binds to the sperm receptor, and that is like pushing the button to lock all the doors. And the whole egg shuts down except for where you hit the receptor and you get sucked in. Your nucleus gets sucked into the egg. The sperm lock key, you just keyed in and everybody else is locked out. And now the sperm nucleus, okay, no, it cannot be that color. It has to be this color. The sperm nucleus just got deposited in, and it cannot be that size. Like, it seriously is going to be like that size, which means that whatever. Okay, so now the sperm nucleus is in there. Guess what has to finally finish? Yes, finally, after all that, finally, my secondary oocyte can finish meiosis. And we know that it will go through the process of meiosis, and it will actually produce, that's an arrow, oh good Lord, it's going to produce a nuclear bundle called a polar body. And the polar body just gets blooped out, like bloopy bloopness, bye-bye. And now you have an ovum for like half a second before the sperm nucleus and the ovum nucleus combine. And we, oh, I need the perfect color for this. Oh, we made a baby. Okay, I mean, you think all that's cool? Wait till you find out what happens to that little parasite we just made.